So how did Seanergy, a small company from Aberdeen, manage to secure significant stakes in these sites and also get some quite reputable partnerships with both npower, SSE and EDPR and Taiwan Generation Company? Well, it's partly because of the oil and gas experience of the company, because the skills are very much transferable from the oil and gas sector into offshore renewables, but it's also attributable to the performance of the Seanergy management team in delivering the Beatrice project. Now, the Beatrice offshore wind project was a technical demonstration project. It wasn't a commercial venture. It wasn't the first offshore wind farm in existence. There were wind farms in existence prior to the Beatrice demonstration project, but they were close to shore in very shallow waters. And they were effectively executed by onshore wind farm developers that had ventured into the offshore environment, albeit close to shore and in very shallow waters. What we embarked on in the Beatrice demonstration project was to deploy large turbines distant from shore in deeper waters. And like Steve referred to earlier, when you look at the environmental conditions associated with the deployment of these two turbines, it's very similar to the environmental conditions associated with the bulk of the acreage that's going to be awarded in UK Round 3. So I'd just like to talk through the sort of key technical challenges that we overcame during the execution of that project. First of all, we opted to use the 5 megawatt turbines, the two repower 5 megawatt turbines for this demonstration project. And why did we use 5 megawatts? Because it was the largest turbine available. Like any offshore infrastructure, the more generation you could get out of that platform, the better it makes the project economics. So the larger the turbine, the better for the economics of the project, providing it's a reliable turbine. It was also the first deployment of turbines distant from shore. These two turbines were 23 kilometres from the nearest coastline and in 45 metres of water depth. Now, from an oil and gas perspective, that's actually very close to shore and very shallow. But for offshore wind, it was a step change for the industry. It was also the first time that we'd used a jacket substructure to support the turbine. And if you're unfamiliar with the terminology, the top left-hand picture shows you a typical jacket structure, which is tried and tested technology in the oil and gas sector, but again, this was an industry first for offshore renewables. Prior to the Beatrice demonstration project, the foundation of choice for offshore wind turbines was a steel monopile, a single steel tubular, which is the right foundation. It's the cheapest foundation that you can have. But that's good for shallow water and smaller turbines. Once you get into deeper water and larger turbines and the associated increased loads, the monopile is no longer a technically viable solution. So we looked at technology that had been developed in the oil and gas sector and selected the jacket substructure as a supporting unit for the turbine. The other lesson that took us a lot of years to learn in the oil and gas sector is it's much cheaper to do things at an onshore location. And it also minimises the risk during the very time-sensitive period when you go for the offshore installation. So one of the key aspects of the project was to maximise the state of completion at the earliest point in the process. So we opted to fully assemble the turbine, and you'll see this in a second. We've got a video showing the execution of the project. We decided to fully assemble the turbine at an onshore location and transport it to the offshore installation site as a single unit. We also used a floating vessel for doing the offshore installation. And again, the benefit of doing that was that when we knew that deployment at scale was going to come round the corner, the more vessels that you could make available for addressing this huge market opportunity, the better. Up until the Beatrice project, contractors had essentially used jack-up platforms because they were in relatively shallow water. So they would go out with a jack-up platform, jack down the legs, sit on the seabed, and do their stick-build approach like they have done at an onshore location. Like I mentioned, we opted to fully assemble the turbine using a floating vessel, take it out to the field, and install it on the pre-installed substructure. And you'll see that in a second. And that also confirms that the installation of fully assembled turbines can take place in any water depth if you're using a floating vessel. And the last point here seems relatively minor in relation to the preceding 5, but it's the successful development of a safe, reliable access system. And that is of paramount importance when you're going into an offshore environment. You need to be able to ensure that you can transfer people safely, and not just safely, but when you need to get them onto these turbines. Access to ensure maintainability and operations is key for the offshore economics of these projects. We developed an access system that would enable you to access these turbines in greater than 2 metre significant wave heights, which is pretty hostile conditions. So you can pretty much gain access to these offshore turbines all year round.